Hello, and welcome to the session on architecting AI-powered organizations. As you know, explainable and trustworthy AI is both a technology problem and a business problem. In this session, I'm going to talk about what leaders need to do to build explainable and trustworthy AI, and to bring stakeholders along with them on their organizations and indeed their nation's AI journey. I will take you through some stories and experiences that you can relate to, where mistrust in AI arises from, and how trust can be rebuilt through explainability. My name is Shefali Yogendra. I serve as a board director of 2 listed companies. I'm also a governor of a university where I oversee audit and risk. Earlier, I worked in an explainable AI company where we built solutions for companies in regulated and safety critical sectors. All my roles have required me to be as good a steward as I can be for a wide range of stakeholders and their interests. This means that the topic of this session is of as much interest to me as I hope it is to you. So thank you for joining me. Now, since this is likely to be a diverse audience, let's start with some definitions. If we were in the same room, I would do a show of hands. Unfortunately, we are not in the same room. So I'm going to lean on some past experiences. When asked to define AI, people bring up a wide range of words and phrases and conceptual ideas. They mention robots, algorithms, machine learning, self-learning machines, machines trying to behave like humans. But the funniest one that I encountered in a talk I gave was machines that human beings think are behaving like humans. For the purposes of this afternoon, let's define AI to mean real or virtual machines that can learn, reason, and act for themselves. These machines can make their own decisions. And when situations change, we expect AI or these machines to be able to deal with the new situations, just as a human being or an animal might. In common usage, however, the term AI has come to be used interchangeably with machine learning, which, as you know, is a technique. Machine learning uses statistics to find patterns in large structured data sets. And these patterns can then be used to make predictions, make recommendations, inform decisions, or make more accurate decisions. You may have read about the recent Alpha Dogfight contest. Yeah, you heard that right, Alpha Dogfight. It was coordinated by the Defense Advanced Research Project Agency, or DARPA, in the US to showcase how AI could undertake mission-critical military tasks, which had earlier exclusively been done by human beings. In the Alpha Dogfight contest, a machine learning trained algorithm went head-to-head with a real trained F-16 pilot using a VR headset and simulator controls. You can almost guess the outcome. The AI beat the pilot 5-0. Closer to our daily lives, there are more mundane applications of machine learning around us. Financial services companies, for instance, use patterns to detect fraud signatures. So when your bank calls you because they suspect a fraudulent transaction, it is relying on this pattern recognition to identify the aberrant activity. Netflix, with whom we have probably all become too familiar during lockdown, has an algorithm that recommends things that we might want to watch next. In order to do that, it draws upon the behavioral data they have collected on us. For instance, what we have watched, how much of it we have watched, what we downloaded or saved but never watched, what people around us in our country or in our city may be watching, even what we do and do not accept from the recommendations and how we interact with those recommendations. Everything we do is data that can be used to further train the Netflix algorithm. But in experiencing all of this, we have also experienced the limitations of such AI. I recall a story from about 20 years ago. In 2000, one of my closest friends was expecting a baby. I sent her a funny book on pregnancy via Amazon. After that, Amazon showed me pregnancy books for 8 straight years. Now, you'll agree with me, that's not terribly intelligent, artificial or otherwise. It's completely devoid of context, and it really got borderline silly. And then it stopped. To be fair, algorithms have gotten better and smarter since then, but they're still not perfect. They're not all comforting, and they are not always put only to benign uses. We have developed further insight into deep learning, which has given us hyperreal photographs, but also potentially problematic, more accurate facial and voice recognition, and deepfake audio and video. Some believe that with enough data, we may reach artificial general intelligence soon, but currently we are not close. Even in benign contexts, missteps occur, and they are widely publicized, and they can be quite expensive to fix. You may remember a few years ago, we learned about Amazon's hiring algorithm. It was built using Amazon's data sets of previously successful candidates, and it was meant to process the CVs, inbound candidate CVs that Amazon receives, presumably in large numbers. As it was being trialed, it was noticed that the algorithm was not putting forward any women candidates for interview. It was overvaluing some activities and undervaluing others. But specifically, it was deprecating women candidates, their colleges, their club activities, their sport leadership activities, and so on. This was clearly a problem. The algorithm had automated past hiring biases at speed and at scale. But once the problem was identified, Amazon's cracked the project. There's a technical lesson here, of course, which is training data sets matter in machine learning a lot. But there is another crucial lesson, and that is it was human oversight of the output that identified the problem that needed fixing in the algorithm. So problems like this are not entirely unsolvable. They can be solved, but they can perhaps be solved more easily at a company level than at a country level, because at a country level, the complexity grows tremendously. Stakeholder groups and concerns are many, and their concerns must be paid attention to. Recently, I have been serving on the external advisory group to UKRI to help define the AI strategy for the UK. UKRI, as you know, is the public body that directs research and innovation funding in the UK. In turn, it is funded through the science budget of the Department of Business, Energy and Industrial Strategy. UKRI delivers on its mission via 7 research councils and Innovate UK. So the AI strategy for the UK intends that the AI developed in the UK benefits society, provides skilled employment, and delivers significant economic growth. This is anticipated to be achieved by increasing investment in 2 major strategic areas. 1, developing new AI technologies and unleashing business innovation. And 2, building the right environment for AI research and innovation to thrive. Of course, these are big goals. And success with these big goals will require that we bring along all the stakeholders with us on this journey. And these would be citizens, consumers, researchers, businesses, employees, shareholders, regulators, civic bodies, various interest groups, and so on. And all these stakeholder groups don't all have the same reaction to AI. So when AI is mentioned, there are those of us that are excited by the visions from popular science fiction. But there are also those amongst us that worry about losing their jobs to automation. They worry that their skills and capabilities may not remain relevant in the future. They worry about loss of agency, loss of control. And this fear is understandable. Leaders in AI, whether they're building AI or they're implementing AI, must acknowledge and understand this fear. This fear in stakeholders often arises from lack of trust in the AI that is being built and implemented. It is difficult to trust AI, but it's unfortunately very easy to damage the trust through incidents such as the recent grading algorithm fiasco in the UK. Up to 40% of school leavers received different grades from what they had expected. It distressed them and their parents and guardians. It left universities working overtime to deal with the fallout over admissions. So several scholars and technical specialists have since looked into the grading algorithm and written about it, so I'm not going to rehash it. Also, the decision was reversed under considerable pressure, and that's where I want to focus because there is a lesson for us here. An engaged and vigilant stakeholder group is essential to algorithmic accountability. Unfortunately, a lot of damage to AI was done with this incident. Nearly every AI story that has appeared since then wants to make an obligatory mention of the grading algorithm in the opening bars. It just makes things worse. But leaders in AI must acknowledge what it is telling us. there is a need to rebuild trust in AI with all stakeholder groups. Because it's not just us citizens and consumers that need to know why the computer said no. Businesses that operate in safety critical and regulated sectors also need to be able to trust the AI they deploy, because they often need to explain themselves, whether it is for compliance purposes or it is to deal with an appealed outcome of a decision that the consumers want to appeal, or to address questions, for instance, from auditors who are having to look deeper and deeper into companies' decisions before they sign anything off. When governments and democracies implement AI in their decision-making, they are expected to act with fairness and accountability towards the outcomes and towards their second and third order effects. They need to be able to trust the AI they deploy as well. So how do we build trust in AI? Several approaches are being trialed. Some time ago, you'll recall the French government stipulated that the software code for algorithms deployed in the public sector should be made public. Great gesture, not terribly helpful. Users of AI should not be required to troll through software code to unravel the mysteries of the AI and how it's functioning and how it's making decisions that impact their lives. AI that supports decision-making should explain itself and its workings. It can take a cue from our high school experiences. In the maths exam, a question worth 10 marks, you would still get 7 or 8 marks if you showed all the steps that you take, whether or not you finished the whole exercise and arrived at the answer. Contrast it with how the teachers marked the students who just wrote the answer. AI needs to take a cue from it and explain itself and its workings. Explainability of AI-supported decision-making is important because it can be helpful in shoring up trust in AI. But building explainable AI is not simple. We are making progress, but it's not simple. So there's several approaches. One is, as machine learning algorithms train predictive models, each step can be evaluated for its explainability. Any feedback that's obtained through testing can be used to modify the algorithm. Also, at the level of the algorithm, explainability could be about how the algorithm is learning a model from the data and what relationships it's learning. Similarly, evaluations at a task level can be carried out by an experienced end user who can assess the robustness of the model underlying the algorithm and give feedback, and that feedback can be used to modify the algorithm. Another way to build explainability would be to use only algorithms that can create such explainable models. Now, just between these 4 approaches that I have briefly outlined, there are several combinations and permutations that can be used in order to enhance the explainability of AI. But there's an additional layer of challenge in building explainable AI. If you look at machine learning, those algorithms use large swathes of structured data to produce outcomes, but they're not very good at explaining themselves. When they are self-learning, things get even more complicated. In real life, however, a lot of decisions use unstructured data and tacit expertise. It is estimated that nearly 80% of the world's data is actually unstructured. Now, there's considerable progress underway in using machine learning techniques as well as neurolinguistic programming to make such unstructured data actionable and usable in AI-led decision-making. In the AI company that I worked in earlier, we used to build n-dimensional decision trees with binary branches using the principle of falsifiability. That created a consistent output and an explanation of the decisions that were produced by the model. But this approach used symbolic AI, not machine learning methods, and it worked really well to structure tacit and unstructured information. In many contexts, especially safety critical or regulated ones, which need to have low error tolerance, human oversight remains crucial. Automation may create problems of non-transparency and non-compliance, but automation can also augment and speed up human decision-making. So in complex contexts, the use of AI benefits from human and computer collaboration in decision-making. Back to our core question. What can leaders do to build trust and to bring stakeholders along on the AI journey, whether they are building the technology behind AI or they are implementing AI solutions in their organizations? So here are some actionable steps. First, Technology and business leaders must acknowledge stakeholders' fears and concerns and do so proactively. This requires leaders to not only listen, but also spend time understanding the second and third order effects of implementing AI-supported decision-making. Second, leaders need to build and promote explainability and transparency. This is important when the technology is being built, when it's being implemented, and how organizational culture is built to support these aims. Third, leaders need to be savvy to the context in which AI is being implemented. Each context brings its own risks and accountability requirements. In complex or safety critical or regulated contexts, automation and AI can be used to augment and support human decision making, not just simply to override it and leave it unexplained. Crucially, these steps are not one-time actions, they are iterative. They require the leaders to remain engaged with the stakeholders as the AI solutions get implemented and more is learned about their real impact. And finally, if things do go wrong, which they sometimes do, leaders must recognize it and apologize for it. That apology can open the door to a conversation and feedback that can lead to restoration of trust, both in the leaders and in the AI technology itself. So we are reaching the end of this session. At the beginning, I mentioned that all my work is about being as good a steward as I can be for the stakeholders that I serve in my various roles. The actionable points that I've just outlined have come from my own and others' experience of building better governance, better accountability, and better trust. But I prefer to end on something more uplifting and amusing, which you will remember more likely than the rest of the talk. British science fiction writer Arthur C. Clarke wrote, "Any sufficiently advanced technology is indistinguishable from magic." But to bring the discussion of explainable and trustworthy AI more up to date in pop culture, we will turn to Doctor Who instead, who said, "To the rational mind, nothing is inexplicable, only unexplained. So let's together unpack the magical black box of AI so we can understand this better and trust it more." Thank you so much for listening.
Thank you, Shefali Yogendra, for this positive and insightful presentation. I'd like to thank you in particular for debunking some ideas about AI and for suggesting some recommendations for leaders to enhance trust, such as by engaging and communicating, acknowledging concerns in particular, because often the lack of preparedness of organizations come from the apprehension and the lack of literacy or knowledge or understanding of people in organizations. And thank you as well for raising the need for quality training data to overcome some of the well-known and often debated issues in AI use and development. I think it's important to indeed discuss a little bit, you know, where does this fears of AI come from? And often it's because there's a certain type of AI, which you mentioned, the artificial general intelligence, that would be imminent and feasible and would exceed human intelligence and replace human jobs. But very often computer systems for now can only mimic our human brain. And a lot of those technologies are already in the marketplace, but they remain expensive and not powerful enough to really be scaled or deployed at scale. I'd like to come back to a point of the discussion that you touched upon, which was about the bias. And you know, I believe humans are also very imperfect in their decision making. We're influenced by the weather, by our mood, if we're hungry or not, and by our stereotypes. And the hope with AI is that those systems could be fair in theory, because they would be more consistent, because we could consciously decide which information we want them to use to make a decision, and the information that we don't want them to use. Companies are actually using AI, for instance, to find qualified people for hard-to-fill positions, that increase diversity in teams. So my question for you would be, are we not subjecting a technology like AI to standards that are higher than the ones we impose to humans, like recruiters, judges, or pilots. What are your thoughts on this?
That's a very good question, Eileen. Are we not subjecting computers to a higher standard? If you look at the conversation about inclusive leadership, which has been brewing in different countries for the last, I think, about a 10-year period, definitely, if not longer, you will see that we are subjecting ourselves to the same standards increasingly as well. We, for instance, in the UK, if you look at board level, the 30% club worked really hard to ensure that the largest employers, largest companies, the FTSE 100 companies in this country, had boards that were representative of the society that their customers and employees came from. It took them about 10 years to make these boards, drive the change that made these boards about a third women. So there is change brewing everywhere around us. And in the summer just passed, I don't know whether it's over yet, but I think it is over. In the summer, we saw quite a lot of protests about Black Lives Matter. And those protests were not limited to the United States, although they started there. We saw protests here in the UK in several cities, London and Manchester, for instance. We also saw protests in Europe and several other countries outside Europe, which, at least speaking for me, I was quite surprised by, because I hadn't quite understood the chord it struck with people. So there are people around the world now questioning the biases that we operate from, asking questions related to ethnicity and gender, which are external presentation factors, are the easiest questions to ask. Speaking of my experience on one of the boards, one of the challenges we have is that we would like to represent the community that we serve. But if we don't have complete data on the people we already have in the leadership team and on the board, we are not going to be able to identify the gaps so that we can take action on them. So we are not really subjecting computers to higher standards. We are hoping ourselves to raise our game to those standards. And therefore, we are more cognizant of the gaps we are automating, perhaps, which is why there is such a big deal of, made of the emphasis on good quality data sets and on eliminating or minimizing bias as far as we can through models and from data that we use for training.
Thank you very much for your response. Yeah, data quality is indeed the crux of the matter, isn't it? But when some people are talking about, for instance, facial recognition technology and that we should ban it, there have been discussions at the Commission level, but also within activist groups who would prefer that we don't deploy that technology, that we don't use it. How do we make better, how do we improve a technology, without implementing it, without trying it out? While China is definitely doing that, getting better at the technology than we are.
I think it is difficult to strike a balance in something which is new and emergent and exciting. So on the one hand, when we wear our consumer hats, we are very happy with the idea of being able to open our phones or pay for something using our face, using facial recognition technologies. But we are also citizens, and we may be protesting something, and our employer might not like it. Or if we are not lucky to live in a democracy, our government may not like it. Then it becomes a weapon in the hands of the people who have more power over our lives than we realize. So there are some benefits and there are some potential risks. This is why accountability mechanisms are so important. The governments of various countries, as well as employers, should be very explicit about the way they are going to deploy technology, what their policies of using the data are, and how long they hang on to the data, for instance. So this is an ongoing live debate, because there are quite a lot of things which are very unique to us. Our face and our iris recognition, our fingerprints, they are amongst those. Once they are in a database, they will, if they are not removed, they can forever be used to tie us to something which we have moved on from, because we are evolving people. We evolve in our ideas, we evolve in our beliefs, we evolve in our understanding of issues. So it's a live debate. In some situations, such as security of buildings, etc., people may have some rights in order to deploy facial recognition so that they can identify criminals and so on. but they also, the same technology is used to figure out which employees are coming in at which time and leaving when. So I think having accountability mechanisms and transparency, as I also mentioned in my talk, is one way to build trust. And then one of the things that I also believe is that trust is not a one-time thing. Trust is a renewable license. With every action that somebody takes based on the information available to them, they tell us whether they are trustworthy or not. If we have a track record of trustworthy actions from governments, from employers, from other people, then we can continue to trust the technology as well, because people are essentially the ones making decisions. It is not a one-time thing.
That's a very good point, but I'd like to challenge you on that a little bit more, if I may, because these concepts of AI trustworthiness and ethics are heavily debated, and there are many ethics guidelines out there. The requirements that they would entail may not be always practical and actionable for some companies, for some developers, for some AI systems. Criteria like human control could be impractical in some ways. It also defeats the point of AI. If you look at the human control as a sine qua non condition to the performance of systems. When it comes to explainability, is it not true that there is this black box issue that still remains for AI systems? So if we impose explainability as, for instance, a one-size-fits-all requirement for trustworthiness, that may be difficult. For transparency, also you have issues of security, privacy, and trade secrets. So how do we find a way around it so that in the meantime, while we get those techniques that can improve AI explainability or that can lead to regulations maybe and principles actionable in practice, how do we make sure people don't fear the technology in the meantime?
I think that's a circuitous sort of process we are in, right? So we trust something that we see to be consistent, or that we at least see to be reliable. It gives us the correct answer no matter what question we ask it. So I think correctness and consistency are two things that if technology delivers it, people aren't likely to fear it as much as they are likely to fear a black box that doesn't explain itself, gives you an answer, and doesn't explain anything, whether it hurts you or it benefits you as a human person affected by that outcome. So key things to me would be correctness that's consistent and delivered regardless of the question we are asking that system, as long as the questions being asked are within the parameters for which the system was designed.
And what is, maybe one final question, what would be your advice to European businesses that are developing AI? Where should they get the information to facilitate the deployment or use of AI in their processes?
I think one of the things is to ask the technology vendors what they are doing. How does their technology actually work? And you'll be surprised how many vendors can't explain how their technology works. So that's not really helpful. As I also mentioned in my talk, there are two components to it. There's the technology leadership component, and there is the business leadership component. If the technology leaders can explain what they are building and how it works and what its foibles might be, then the business leaders are going to be able to discuss more clearly and openly with the stakeholders who are affected by the outcome of deploying such technology. So it is a situation where technology and business leadership are not separate. They're supposed to work hand in hand. But the more transparent and more self-explaining they are, it is likely that they are going to engender more trust in the people, in the stakeholders that are affected by the AI's deployment.
Thank you so much, Shefali Yogendra. It was a pleasure and an honor to have a bit of a conversation with you. Thank you for your presentation.